Hi Sanjeev, can you hear me? Okay, can you hear now? Hello. Hi, actually guys, I'm trying to Hi guys, actually I'm trying to see if the audio for Mohan can be fixed. Okay. Yeah, I think Umang is right. I think that's what I should do. I think that's what I should do. Hi. Yeah, toll free number I'm giving you, Sanjeev. I'm giving you a toll free number. Okay. I'm not sure that it'll be completely toll free. Or what you can do, Sanjeev, that you can call me via Gmail, and then I'll pick that up on my phone. I'm sorry, he can't hear anyway. Okay. I'm sending you the detail, Sanjeev. Okay. But or you can dial me on my Gmail ID, Sandeep Giri, via Hangout. Hi, sorry guys for so much of disturbance. Okay, and okay. So we were talking about the cursors. Okay, so if you have any cursors in the server, they will be listed under here, and the details will be there. Okay, all the details about the cursor will be listed over here. If you say db.server status, then you'll get that. Okay, okay. Now there was another question. Okay, question number 20 of 27. It is possible to guarantee that the record has been replicated while inserting using right concerns. Okay, okay. So question number 27 was supposed to be addressed after the today's talk. Okay, and yeah, so some of the portions which we discussed last time uh, has been spilled over to today. Okay, with respect to the right concerns and all those aspects. Okay, so those will be discussed today. And any other question did you have before we start today's class? Okay, okay. So any other questions with respect to the session? And so quiz, uh, this quiz anyway finished. This quiz also you have finished the second quiz, and yeah, today's session will be available very soon. Great, great. So this class is probably the most active class amongst all my classes, in which everybody actually finishes assignments on time, before time, and I'm happy to have this kind of class. So this is our session number 3. Okay, so Wahid's question is, can we do auto increment? Okay, without having a separate table. Um, no, basically you will have to maintain the max counter somewhere. Okay, to do that, to do the auto increment thing. Okay, uh, yeah. So auto increment is not by default a property similar to RDBMS. It's not a feature provided by MongoDB, but you can anyway emulate it. Okay. All it has given you, there is a INCR function. Some of you have actually done that way. And using that one, what you can do is you can make sure it is atomic. Make sure it is atomic. All right. That INCR, I mean, okay. So who understands the meaning of atomic? Can somebody explain? Atomic function. When I say this function is atomic or this operation is atomic, what does it mean? Yes, I'll take a practical example. So when we say something like atomic with respect to transactions or with operation, we mean to say that either the whole of the operation happens or it doesn't happen. Okay, so increasing any number or increasing any value involves two things. First is reading the current value, increasing it, and then saving it back. So basically three steps are there. Okay, so if while you read it and somebody else also read it and you are trying to write it and somebody else writes it before you do, that means you will overwrite somebody else's value, and and uh, and there will be inconsistencies. Okay, so for example, imagine that your basically bank account, for example. So you are trying to do transaction somehow by two from two places simultaneously. You deducted your account, you trying to withdraw 100 rupees from your account, and your account has 500 rupees, right? So say when the machine is trying to check what is the current balance, and before deducting 100 rupees it read it's 500, then it deducted 100 and then tried to save it uh, as 400. In the parallel there is somebody else. Okay, there is some other basically somebody else also trying to do the same thing. Okay, somebody else is trying to do the same thing. Now now see, so they also read it as 500, and then they are saying deducting it 200 from the account and saving it back. So now at the end of the day you saved it 400 and they are saving 300. Okay, so effectively your account will be left with 300 while there has been a withdrawal of 300 rupees, which means ideally there should have been only 200 left in your account after the withdrawal of 300, but it is 200 is still left. Okay, so there should not be any difference, any time difference between reading and then changing and writing it back. Okay, so that is why these atomic operations are invented. Okay, and those are the basic definition of the acid properties of database to avoid this kind of problems. Okay, so A for atomic in the acid properties of a database stands for this kind of property. Okay, atomic means either happens or don't happen. There is nothing in between, and the other parties do not see any intermediate states. The way they saw in the example just now, when you read 500 and then you're trying to change, somebody else read it as 500, they too read it at 500, and then they are also trying to save the same thing as you are. So this kind of fault of the database should not happen. Okay, Eh, because these are very important things. In certain cases you do not want this kind of problems to be occurring at all. Okay, for some cases it might be okay, but for some cases it is not at all accepted. That is why almost every database gives you a way to do the atomic operations. Okay, and INCR is such atomic operation. So the INCR increase any value by 1 is actually atomic operation which gives you the newer value in the return. Okay, so it increases and then saves the number back by 1. Okay, and then it gives you the new number, the increased value. So did you get the idea? What did I mean by atomic operation? Ranjita, Pramod? Great, great, great. Okay. Any other questions before we move forward? Okay, great. So today let's talk a bit about query optimization. So we talked about CRUD operations, whereby we were doing creation, retrieval, updation, and deletion. So while you are retrieving any of the documents, it needs to be optimized. The whole process of retrieval has to be optimized. Okay. And the retrieval way, we have just read only one, which is find. We say db name dot find, and then we will give the conditions and followed by a projection. That's what we do when we do the retrieval. All right. And to make it to make it to make it really really fast, people have come up with something called indexes. And indexes is exactly what your book has. So the way you see the indexes in front of the book or at the back of the book, that is what an index is. Okay. In the front of the book, it is title wise, topic wise, where you can search, you can jump to the particular chapter or particular in the sequence. While at the back of the book, you will see those you will see those keywords. And if you are looking for a particular keyword, and then you can just quickly jump into the index and find it there. Similarly, Similarly, almost every database comes up with an idea of index, whether RDBMS or whether it is MongoDB or Cassandra or HBase. HBase doesn't have, but everybody else has the indexes. Okay. Now, why does it become faster when we create indexes? Okay. So let me, I think I have an example over here, right? So sequentially, so you have say 1 million records in a table, right? And in that 1 million record, first one is an ID, say as a company ID, and second one is the company name. And now you say you are looking for a particular company name in this table. One way is you start reading it from top till the bottom, comparing the company name with the string you are looking for. Or you could do a better option. Okay. What is that a better option? You create an index onto the company name. And what does it mean by creation of index? You take all the distinct names, make a list of those, and also note down the page number and the line number and word number. Okay, the location in that line. Okay, in front of each word. If this word is existing multiple times, you put those numbers in front, comma separated values. Okay. So you mention all the places you found a particular word in this index, and this index is ordered by ascending order or descending order, right? So all the keywords which you found in all the words you found in company name, you ordered them alphabetically. In front of each company name, you have put a location where did you find it, okay? Or you have put the row number in front of every every word, right? Now this is called an index by company name. Now when we are looking at this index, all we have to do is do a binary search. Binary search, what does it mean by a binary search? Okay, binary search means that we will not be going from top to bottom sequentially. Instead, we will jump to the middle of the whole text and see whether the word which we are looking for lies above or below the current position, or it is at the right, or we have found the word. Okay, so this kind of searching is binary searching. So so it's like you take a whole dictionary and you are trying to find a word. So you open the dictionary from the middle, and then if that word is on that page, it is okay. Otherwise, you know whether to go whether to search in the left section of the dictionary or in the right section of the dictionary. Okay, so that is what is a basically a binary search. So is binary search clear to everybody? Because binary search is the key idea. Or let me ask you, is it not clear for anybody? I'll try to answer that. Okay. So binary search is the key idea behind indexes. Okay. On the lines of binary search, there are multiple other. So why do you want me to repeat? Okay, okay. So okay. So basically, let's say you have a no. Anuj, that's not the way. It is a very simple than that. Okay, I'll explain to you. So you have how should I need a text, a big text. Okay, okay. Say you ask me, I ask you to think of a number between 1 to 100. Okay, you have thought of a number, say 45. Okay, I don't know that yet. Then I start guessing. Is it 0? You say no, it's greater than 0. Then I say, is it 100? Then you say no, it's lesser than 100. Then I say that, is it 50? Then you say that no, it's lesser than 50. Okay. Then I say, is it 25? I'm jumping between. Now I have to jump between 0 to 50. Okay, right? Now I say, okay, is it 25? You say no, it is greater. Okay, you say greater. Now I have to I have to guess between 25 to 50, right? Now I'll say something like 34. Okay, you say no, it's greater still, and I will keep on doing it. Okay, so next answer will be 42. Okay, 43, 42 actually. Okay, and okay, because 34 and 50, I'll say, is it 42? Then you say no, it is greater. And then next, in the next one, what I'll do is I'll do so I have to search now between 42 and 50. Okay, and that is the way I will probably reach to 44. Okay, great. I'm very happy, Sanjeev, you are able to hear. So I'm trying to explain how does a binary search work. Okay, the behind the indexes of any table, the binary search is the basic idea around which around which it is around which the binary search is completely revolves around. Okay, so the idea is that, say you have got one 10,000 strings, let's say 10,000 strings. Okay, so um actually it's difficult to come up with data set quickly. Okay, so let me say, okay, okay, and so on. Okay, right, so this way you have got a huge set of text. Okay, now you are looking for particular uh, word, right? So what you do is, first you try with the first one, then last one, then you jump right into the middle of it. Okay, and then if that middle one is the correct which one you are looking for, then you compare your word again. I mean, you say that this is the answer. Okay, otherwise you know that whether to search up or search in the downwards, right? Let's say you ask me to find the tree. Okay, let's and there is a row number against each one. Okay, right, so you ask me that, can you tell me the row which contain the tree keyword. So I'm going to look into, this is the index. Okay, this is the index which is ordered alphabetically, and this is the word which we are looking for, comparing against, and this is the row number. Okay, so this is how an index looks like, exactly the way the index is located at the back of your book. Okay, word against the line number. Similarly, an index is word against the line, against the row number, and these words are ordered by alphabets. Okay, similarly, in case of a book, you have only single index. In case of a database, there could be any number of indexes based on which column are you creating the index on. All right. So Anuj, was I able to explain, or should I take a better example? Okay, I was not able to explain. Okay. Okay, let me read Wahid's answer. He says, okay, just right. So Rajita's point is that, is it similar to data structure in binary search? Yeah. So binary search is not a data structure. It is basically algorithm. But binary search tree is the data structure, and it is exactly similar to that, Rajita. You are very right. And let me just go through Wahid's answer. Okay. Anuj is saying, when searching text, how does it work? Okay, let me explain again that one. Don't worry. And divide the numbers into the range, so on each range it will skip the previous one, and so on. Yes, it is sort of that one. So you keep on dividing the whole range into half and half, and you keep on discarding one half, or you keep on looking only in one half. Exactly, exactly. So this is the way uh, Umang is right. Yeah. So, Anuj, not really. I'll tell you that uh, for sorting anything, you don't need to convert everything into number. Okay, you can order internally. It will be a number only. Okay, it'll be a number only. Okay, but when you are dealing in the program, you don't have to worry about it. All you have to do is take all the string, order them alphabetically. Against each string, you keep the number against it, and then you keep on searching. Okay. Hope I'm not confusing you guys. Okay, so basically it's actually very simple concept. It's exactly the way it looks at the back of your book. All right. Okay, so Rizwan's question is how it decides dog is smaller than elephant, right? So basically we compare D and E when we are ordering only. Then at that time when we are converting the whole text into sequence, that time we do compare, like D comes before E. D has a ASCII value which is lesser than E, which means that which means dog is smaller. Had it been bigger, then D could have been bigger. If D and E would have been smaller, it will keep on going till the point either one of them ends. The one which ended will be smaller than the one which has not ended yet. Okay, so this is the way it is decided. So the ASCII is the base point of searching. Yeah, and I mean it so happens that the ASCII values are 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 in the alphabetic order, meaning the value of A is one less than the value of B, and the value of C is one less than value of D. But value of capital A is greater than value of small z. Okay, so ASCII value cannot be really a foolproof method. So whosoever is writing an algorithm generally takes care of these parts, and almost all the programming language takes care of this. Okay, all the programming language takes care of this. For example, I think JavaScript also takes care of. Okay, so as you can see my screen, is it visible enough? So even the JavaScript takes care of this. Okay, right? As you can see that A is less than Z, right? Okay, so capital A is less than, and capital Z is less than small a, if you can see that. So yeah, so basically this is how a searching or indexing works on any of these strings. Okay, so here we have created an index based on the company number, and each of this index is having a pointer to the row. Okay, so that means we do not have any such problem. Basically we can, when you are searching, you keep jumping. Say for 17 you jump, so you first look at the top, say oh it's 13, and then go to the bottom, it's say 23. So now between 23 and 17, whatever is your middle row, you jump to that one. Okay, here, and then you say oh I hit 17, I'm happy. Okay, so most of the algorithms in computer science actually started with the binary search, and it's a very very key concept behind searching. Let me ask you this quick question. Okay, so while scanning, so you have got, say, how many, so these many rows are there in a table. Okay, and if you go row by row and search, if you go row by row and search, your it takes around, say say 10 hours. All right, it takes around 10 hours. Now if you jump in the binary, if you use index, how much time do you think it is going to take? So say you have got this much, how many are they? uh, Say 10 million rows. Okay, you are searching row by row from top to bottom, and to traverse the whole table it takes around 10 hours. Okay, or you can say these many minutes and these many seconds. So this is what it takes to, say, search these rows. I mean, look for a string in this table if you go one by one. Now, can somebody tell me that in case and say each comparison takes around, so each comparison, how much will it take? Okay, so each comparison is around taking 277 seconds. All right, this is actually too much. Or we can say that we have got these many rows, 3, 3, and 3. 1 billion rows we have got. Okay, and this is what it takes, 36,010 hours. And okay, okay, into 36,000 divided by, say, 1 million rows. Okay, so 1 million is good enough sample, 336, and say it takes, okay, okay, so you have got 10,000 row, and for comparing each value it takes around 36 milliseconds, and hence comparing the whole, finding a particular data takes, on, in the worst case scenario, these many seconds. Okay, which is 36,000 seconds. All right, now say you are using a binary search, how much time do you think it is going to take? Anybody? Can anybody answer this? 10 to 15 seconds. Okay, 1 second, 12.5 seconds. Okay, okay, so the way you compute is you take these rows and take the log base 2, and then you multiply it by 36. Okay, so it takes less than a second. Okay, 0.717 seconds. Okay, and how did I do it? Because I'm going to jump into halves, which means the total number of comparisons which are going to be there are going to be log to the base of the total number of rows. Okay, and then basically total number of lookups, total number of times it has to compare in this is around 20. Okay, so in 20 comparisons, just in 20 comparisons, it is going to reach to what you are looking for. Okay, right? So in just the 20 comparisons, it is going to reach to the number you are looking for, and hence it is just 0.71 seconds. It is below 1 second. Now, why I'm giving this example? So whenever you are optimizing any query, whenever you are optimizing any query, remember that remember that it will take it will be very very fast if you do an index. Now the problem is, if you are having these many rows, okay, if you are having these many rows, then the chances are when you are creating an index for the first time, if you're creating an index for the first time, it approximately will take you 36,000 into 20. So 20 times, basically it will take 20 into 10 hours for creation of the index in the beginning. Okay. So when you are ordering these rows, okay, if you're ordering these rows, that means there is a cost associated with it. There is a cost associated with creation of index also. So in the first go, what you did was you created the index. Now you are looking it up. Looking up is extremely fast. It takes less than 1 second, but index creation is costly. It will be equivalent to 20 into the, I mean, log of the total number of rows into the uh, single scan time. Okay. All right. So remember that creation of index does improve a lot of lookup. Right. So it is, yeah, but for pre-populated table, yes. But in case table is being increased also, then also the inserting a single record will have some latency. You will add a record into the table, and when you are adding a record, you will also add a value into the index. Okay. In those cases, like we gave an example here. Okay. Here we talked about. Right, right. Not only padding, but Anuj will have to find that location where does a particular value belong to in the index, right? The way we took an example just now, and say we are adding something called queen in the list. So queen has to go between elephant and zebra. First, we have to find that location. After that, once you found that location, if the padding is available, you can insert it there. Or if the padding is not available, or it's a fresh doc, it's basically not available, then there will be a movement. So if you take into account, then it will not be an issue. Okay, but uh, that movement is very well minimized by using a concept called binary tree. Okay, binary tree. Okay, you keep on creating nodes between the left and right. All right, but that's little too advanced for the today's discussion. Okay, so and right, so while index creation and insertion are the two time consuming things, but generally in case of database, most of the database are tuned for 10 is to 1 ratio between reads and writes, and therefore index is extremely helpful. And also the queries which are writing to the database are generally lesser, and people who are writing are less demanding with respect to time. Or databases come up with the concept of ledgers, as in we will let you know once the data is inserted, but we accept your rights. Okay, MongoDB is one such case where index creation, everything else, MongoDB will keep do it in the background while giving the response to the user quickly. Okay, there are various ways. Great. Now we can move on. So I have taken a bit of time to actually explain to you what does it mean by index creation, because this is a very core concept when we talk about databases and indexes. Okay, now how do we create indexes on a particular table? Okay, so all we do is go to the command prompt here and say show tables. So we have got some tables and db.cabs.find. Okay, db.showtables, db.departments.find. We don't have much data over here. db.taxis.find. Show tables or show dbs. Show dbs say use test. Show tables. Test was anywhere. That's what I was using earlier. Use Sandeep and show tables. Okay. db.x.find. Okay. Okay. Never mind. I don't have much right now. So basically, the way you do is that you say db dot. I should take somebody's example. Okay. db dot departments dot find. Okay. Right. So here you can create an index on any of the documents. So any of the fields in the document. That field could be inside another field. All right. Say you have got a document like this, and it has got say name, and it's called Sandeep, and then we have got another thing called place, and under the place we have got further the document into this format. Okay, so city called Bangalore. Okay, and here if you have this kind of a database, this kind of table, so let's say we have people dot insert, and okay, so we have db.people. That's fine. All right. Now, other than creating an index on the name, we can also create an index on the city. Okay. We'll deep dive again into all of these concepts. All right. So we can say place.city. Now here, either we can say db.people.ensure index and say name and then say one. Okay. Ensure index. Okay, I need to put curly brackets. Okay. So now the index has been created. Now next time you are going to use something like find name equals Sandeep. It is going to do internally a sort of a binary search quickly and give you the results. Okay. And if you don't believe me, you can do explain, and it will show you that this is using something called a B-tree cursor. All right. These all concepts, do not panic, do not worry right now if you did not understand what I just did. Basically, I'm trying to show you that when I did db.people.find, it did it tried to do a B-tree cursor search, which means it's a binary B tree, which is a kind of a binary tree, but in a little bit different. Okay, it's a specialized data structure. Okay, good question, Rizwan. So the which I forgot to mention, when I said ensure index and said colon 1, it means an increasing index, increasing order. If I say this, okay, then the index, the list as we discussed earlier, will be in the decreasing order. And whenever we are going to look up based on this column, the values which are higher will come up as opposed to the other way. Okay. Right now, if you look up based on this index, all the values will come in the increasing order. While if we look if we create an index based on uh, increasing order, then that will be the list will be coming in the uh, I mean, if you create an index with -1, then it will be a descending order, and hence when you search on this table based on this particular index, the list which will be coming out will be in the descending order. Okay. Does it matter how we store, that is ascending or descending? No, it doesn't matter. It doesn't matter. Okay. Good question. Okay. All right. Now, and by default, it is anyway going to give you the ID, which is very different from what anything which we are putting in. Okay. Now, index optimization is great, right? The only thing is certain operations such as regular expression or not in, not equal to, these operators do not have any impact or do not improve because of indexes. Okay. And we say that the whole index is covering a query if in the find clause or in the find function, all the index which all the fields which we are looking for have an index, then we say that index is covering a query and there is no scan involved. Scan meaning you are not going to look sequentially into the table one by one. Okay, that is generally called a scan. So when there is no scan available, that time we say that this is covering the query. Okay. Okay. Now we have this. When index created on one column as 1, then -1, it means two indexes or one index. It is basically a single index you have overwritten. Okay. What I did just now is that I basically, when you are creating a different descending order, then it is going to create a override that same index. Okay, because when we are looking for the same field, only one index can be used. You cannot use different because this query, if you see, it has no clue whether you are looking for which one are you looking for. Therefore all these indexes qualify based on the field. So can you explain why not in and others have no impact on indexing? Just think about the way we had done. We have uh, thought about our. Did you think about the binary search? Binary search works on the 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 criteria that when you're looking for something, you should be able to eliminate half of the subset quickly. Okay, when we are say doing a regular expression search, okay, regular expression search meaning name is a name should be starting with can start with anything, but should end with z dot plus, say we have a regular expression like this, dot plus z. Okay, and we're looking for this. So we compare the beginning and we compare the end, and then we jump into the middle and compare this one. But we can never conclude that w- we can discard any of the subsets right now. All right. We cannot say that if this regular expression has not matched the middle one, should we look up or look down? Right, in that binary search, that is a fair answer. Or say in a book I say that find out the location of all the words which have uh, q and r both. Okay, say I say that plus q plus r, which means find out all the words in this book which contain Q and R in this order. So does the index at the book at the end of the book help you in this scenario or not? You will still have to look into each words sequentially, even if you are looking in the index. You will go from top to bottom, looking for all the words one by one, whether they contain Q and R in this order or not. Right? So similarly, not in also has the similar kind of property. Okay? When we say not in, one, two, three, uh, three or four. Okay? This is say our operator, and say we say our not in operator, it says that this field should not be there. Let's say my xyz field, okay, should not be in this. So you compared the first record and said, okay, the first record is not there in the list. Then you compared the last one, is not there in the list. Then compared the middle one and it is not there in the list. Will will you be able to conclude that we can discard one of the subsets, upper one or the lower one? Of course not, because it doesn't conclude anything, right? So that is the reason why these operations never improve on indexes. Okay? And not equal to does not say anything, right? Similarly, not equal to also has the same property. Now, so MongoDB, when it is executing any of your queries, will have to choose for the most efficient plan, right? And choosing most efficient plan is a difficult thing for MongoDB. Why? Because the rows are existing in different machines. In case of MongoDB, as I described earlier, multiple machines are going to serve you, right? So a table is existing in different shards, or a collection. Table is an alias to collection in case of MongoDB. So a collection, some of the documents of a collection are in one shard, while some of the documents are in another one. Okay, and so on. All right. Now, when we create indexes, it is created by MongoS, and that data is stored into the database at the shard level. Okay. Now, okay, and that index itself goes back into one of the databases. Now, when we are looking for something, when the Mongo S is going to query, it is going to ask for query plan from all the nodes and has to come up with a proper query plan. Okay, and it has to choose the most efficient plan uh, based on the available indexes, and all the candidates are compared in parallel. Okay, how should I explain this? Let me take a better example. So for each of the queries, what so you are querying again against something called a MongoS. I think I should first describe the architecture. Okay. How many of you are clear about the MongoDB who is not clear about the MongoDB architecture? Anyway, I have not gone into details. I have just discussed very, very briefly earlier. So I'll discuss these things and then maybe you will be able to correlate more. But I'll just, so basically MongoDB uses multiple machines to store the data, and hence once all machines reply and they out of all the plans, it whatever there could be multiple ways to execute a query. There could be multiple ways it can include multiple indexes, right? So it has to figure out which indexes to include and which not, which are to discard, right? Because say one column there are two indexes, one is independent index and there is another index called composite index. Then it has to figure out a way to whether to use composite one or use the independent one, right? So for that it uses all the computers in the parallel and ask all of them ki, hey, what is your query plan, what is your query plan? So all the nodes which are storing the data, they will give out their query plan, and MongoS will decide which one to pick it up. All right. And for understanding the query plan, as I demonstrated, after any of your find function, use explain. Okay, that will give you very very detailed output in terms of like which cursor I'm using. Is it multi-key? Multi-key as in multi-column kind of indexes. We'll come back to those things again. Okay. And these are the bounds, the beginning and the end. And which server are we going to use? Okay. And see, in this one, it shows you MongoDB 3, right? While we are connected to MongoDB 1. Okay. Why? Because you see, because this is a sharded kind of environment. This one is a shard. We are talking to the shard and it is delegating its queries to various table. Okay, so when you say rs.status, okay, not rs, it is called sh.status. Okay, it shows you that these are the databases, these are the various databases available, and this is the machine right now called MongoDB 2 and MongoDB 3. Okay, these are the two machines right now and there is only one replica shard. All right, so that is how it happens. Now let me again, I'm going to get into the detail. So does that mean that each machine node has a different query plan although index column is same? Right. I'll come back to that very quickly. Don't worry about that. Okay. Because that involves a bit of explanation with respect to architecture. But that's a very good question. Okay. Now, this is how a typical architecture looks like when we talk about distributed, basically any distributed system. So you have multiple machines, and this one is regarding the MongoDB installation. Okay. Now, all the there are multiple applications. There's all these applications are there. They are talking to Mongo S. Okay. These are the Mongo S. Mongo S is the Mongo shard. That is the guy responsible for distributing the queries. Okay. Now, as you can see that Mongo S has to further, I think we have already discussed architecture in the last one. No. So Mongo S will have something called configuration servers. Okay. Configuration servers will contain the information about which kind of keys, which IDs are stored on which machine. Okay, which IDs are stored on which machines. Now it has to delegate all the queries to each one, insertion or updation or search query to each one, so that they give their individual results, and then it combines all the results and then send it back. For doing that, okay, now, and these are configuration servers. Configuration servers basically tell you which IDs are stored. Once MongoS retrieves the configuration server, then it talks to the individual one. Or this diagram will be better able to explain to you. So this is the MongoS which we are connected to right now. Okay, this is connected to, this is basically routing its data to one shard, another shard. Two shards are there, and this information, which data is inside which shard, is actually stored in config server. Okay, metadata. Basically, this ID is gone into this shard, and this ID has gone to this shard. This information is lying in the config server. So your application driver or your client is talking to the Mongo S. Mongo S has further divided the data like this. Okay. Now here, if your if your driver is asking for a specific key, okay, say you are looking for a particular key, basically the ID. All right. If you're just looking for the ID values, I mean, basically you can define you can nominate any of the field as ID in your document. And if there is a query on the ID, it's very straightforward for MongoS, because MongoS will ask configuration servers, ki, hey, can you tell me which machine does this ID lies with? Okay. So any query which have a field for the ID column, those are extremely fast, because in that way MongoS does not have to bother any other shard. It, from the configuration, it knows that this is the ID and this ID exists in this server, and it routes the whole query to that particular node. Okay. In those cases, the queries are really fast. But if it doesn't have the shard key, meaning you are querying for non-IDs, okay? As we discussed earlier, in the document, in all documents, there is a field called ID, and based on this field, MongoDB, based on this field, or you can also nominate other fields. But for time being, let's just say that there is this ID field. On the basis of that field, MongoS is dividing the documents between multiple machines. It takes the documents, and based on the ID, if the ID goes beyond a certain value, then it pushes to the next server, and it keeps on doing so. Okay. So if If your query does not have the shard key as one of the parameters, then you are in a soup. Because in those cases, MongoS cannot decide which machine directly it need to send the query to. Okay. In these cases, it basically does is scatter the query, meaning it will ask all the nodes to execute a query and let each node execute your query and give it back the results. And MongoS will do is it will combine all the results and give it to the user. Okay. So this is called scatter gather, meaning it scattered the queries and gathered the result and gave it back to the user. Okay. And in these queries are not very fast because they get executed on multiple machines, but they are in parallel. Okay. They are in parallel. MongoOS itself does not have any state. It stores all of its data in the config server as shown in this diagram. All right. Now, okay, before moving forward, I want to take up Anu's question. Anu's question is that why does it need to ask the plan from A, B, and C? Okay, why does it need to do that? Because say you have a query, it says basically since the index is anyway created and the MongoS label. Now there could be a chance that the field you are looking for is not at all there in all the document in the shard A. Okay, and hence it may not exist in the database at all. Okay, so whenever, so if there is a, if you are specifying, okay, great. So Rizwan's question is that where we get the shard key from. Shard key is designed when you are sharding your uh, collection. Okay, so by default whenever you shard your collection, the key on which it is sharded is your ID. So while you are creating your mongo as kind of cluster, okay, you have put your a lot of data into a collection, but it will keep on doing it on one node. Okay, and the moment you say shard this collection on the basis of this key, it will start dividing it, moving some of its records or some of the documents from one database to another automatically. Okay, for the balancing. Okay, now, so that is how the shard key is decided by you generally, but but and sharding is also decided by you. You need to tell MongoS that hey, please shard this database for me, only then it will start sharding. If you don't specify an ID, then and I think underscore ID column is the default shard keys. Okay, great. And everybody is actually talking to MongoS, and MongoS further delegates the querying to each shard. Okay, if it can't decide, MongoS cannot decide which particular shard to send the query from. It sends it to all the databases and then it takes its call. Okay. Okay. Great. So now let's talk about something called read operations in the replica sets. Okay. So yeah. Okay. 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 Hey guys, how about a break of say 5 minutes? We will come back. Okay, let's take a break of say 10 minutes. Okay, okay. So we'll come back at 3:12. Hello. Hi guys, I'm back. Okay. I'm assuming that everybody is back now. Okay. Okay. Now, when we talk about the other aspects of read operations, we talked about how to make read operations fast by creating indexes and keeping in mind the way it is querying the system. Because if you are not specifying your ID or the shard key, then the efficiency of the queries suddenly goes down. So that's what we discussed just now. Now, the next part about read operations is the basically when you are reading the data, what goes beneath it. Okay. So, and read operations provide you something called read preferences. Okay. You can specify your read preferences like this. Okay. You are saying the mode is nearest and tag is this. Okay, when you're saying find blah, putting your query over here, when you put your query in the find, and then you can say read preference is this one. My mode is nearest and my tags are these. Now, what is the meaning of various kinds of these preferences? Okay, so now if you say this and here, okay, I'll have to reformat it. But let me explain you first. Read preferences, these are read preferences. Read preferences dictate that to who the read operation should be sent. Okay, it could be sent to the nearest one. Okay, nearest, how does it decide which one is nearest? So your driver, which is contacting the your shard, keeps a track of the ping response duration. Okay, so driver is given the list of various kinds of machines, and driver sends a ping to all these machines periodically. Now, as long as the connection is maintained, it keeps a track of which machines are responding faster and the response is coming quicker. So those are marked as nearest, and based on that preferences, you will get the results. Okay, and be, so that is a one mode called nearest. So read preferences dictate that where should the query be going, because as we told, for write operation there is primary, but for read operation there all the members of replica set can give you the data. So which one should be preferred? And by default, if you are not changing or doing any setting, by default the read and write operation basically go from the primary. Okay, so you can make I mean you can say that, hey, I want to read from secondary, I want to read from primary, I want to read from my read preferences nearest. Okay, so that kind of mode you can prefer to when you are reading the data from MongoDB. All right, and also you can specify, if you are specifying like this with the find operation, if you are specifying with the find operation that this is my read preference, then this is called per operation kind of read preferences. Okay, you can specify the read preference on the connection itself while you are connecting to the database. Then itself you can say I want to connect to the nearest server, or you can also say that I want to connect to these tags, and these tags are nothing but various tags identifying your machines. Okay, while you are adding your replicas you can mark the tags. Yeah, nearest is the keyword. So while you are adding machines or replicas, you can define their names and you can also tag each of the machines saying, this is my data center, this is my rack, and while querying, you can specify, I want my data center to be in Mumbai from which I'm reading this. Okay. So similarly, you can basically it's tagging, nothing else but tagging each of the data computers or by data center or by rack or by other any other labeling, and then using that label for querying. Okay. If primary is nearest one, then it will read from primary. Right. Right. Also, if the tagged ones are not nearest, okay, yeah. So what it will do is, out of the tagged ones, it will give you the nearest one. Okay. Out of the tagged ones, it will give you the nearest one. All right. And in case there are read preference can also reduce the latency in case of multi-data center deployment by tagging the request by like this. Okay. And if there are high read volumes, okay, if there are high read volumes, you can basically you know, you can tag it to a particular data center and the reads will be distributed to multiple machines. Okay, if you don't specify that I want a particular machine only, the larger you will keep the selection of the read preference, the uh, the more distributed your scans will be. Okay. And read preference also help you in case of backup operations. So when you are taking a backup, you want to basically read from a machine which is least busy right now. Okay. So in those cases, in those cases, you need to figure out which data center it is, and then you basically you back up from only those machines. Okay. Secondary, tertiary, or you have kept a separate machine in another data center from which you want to back up. So there are various benefits of having these read preferences in place. Okay. And in case of failover situations, you can use the read preference. Yes, yes, tell me, Anuj. Okay, I'm waiting. Okay. So basically it is, I said it is based on both. You can also mark your connection while you are opening the connection. Then also you can specify your read preference. First is that. Second, how do we decide tags? While adding the machines into network, we basically tag them with name value pairs. Okay. It is like having another document. Yes. So since the load is always shifting or changing, very true. How do we decide tags are basically generally very fixed values which you have defined for each node. So tags are of not much use, but mode like nearest or mode like secondary only will help you in these cases. Okay. Or if you have any idea, like most of my read writes I'm sending to the data center which is located in US. Okay. And hence my US machines are generally busy, and therefore I will be able to I should be able to read from I should take a I should hit the Indian servers. Okay. So but there is no straight away mechanism provided by MongoDB to basically identify a busy machine and a non busy machine. Okay. Okay, and these are the various no mode, basically the read preference, the mode which we were talking here. These are the various modes of the read preferences. Primary, when you're installing the MongoDB for the first time, the primary itself will be the default read one. You will have to mark, you will have to configure that you can also read from secondary. All right. Was I able to answer you, Anuj? Basically, it can't identify the load automatically right now as in the current feature sets. Okay. Now the other read preference is primary preferred. Primary preferred as in if there are two machines available, one is primary, other is secondary, then you say that read it from primary. If you say primary preferred out of all the machines, if there are multiple machines available, it will prefer the primary one. If you say secondary, in that case, it is a hard requirement from MongoDB to read only from secondary, not from primary, even if primary is available and secondary is down. Okay. The second one is that secondary preferred. If you have primary and secondary both machines available to you, in those cases, you will read from secondary. Okay. And the fourth one out of it is your nearest one. Okay. And based on network latency and all the aspect, it tries to figure out which one is nearest. It keeps on pinging and keeps on noting down the preferences. And that's how when you're querying, you can specify the read preference. Then you will get the actual right one. Okay. Now we have similar kind of preferences for write operations also. Okay. Now when you are writing, you want your basically you want to also have certain preferences. And what does it mean by writing? Writing is in the form of either inserts or updates. Insert is like this is the document which I'm inserting. Okay, here, and it has the db.users.insert, meaning users table. I mean the corresponding nomenclature in case of RDMS is table. Here it's collection, and these are the field and values. Here I'm saying insert this row into this table. Okay, row as in the name equals Sue, age equals 26, and status equal to A into a table called users. In the MongoDB speak, we call it a collection, and this is the document. A row is equal to equivalent of a document. Okay, and the other is like update. So in update, the first parameter is the filtering criteria. Okay, a criteria on which the search will happen, and this is the basically the update action. What do we want to do? If we say just set, that means we will just add one more value here, add one more value called status equals to A, or if status already exists, we just change its value to A, and nothing else is impacted. If you don't put set here, which means the whole document will be replaced with this document. Okay, whole row or the document will be overwritten. Multi equals to true. If you don't say multi equals to true, that means if the this criteria is matching multiple rows, it will just update the first one, and that's it. Okay, it will just update the first one, and that's it. Now third one is db.users.remove, which means that this is just a filtering criteria, and all the records which are matching this one will be deleted. It also has similar like multi colon true kind of preferences options by which it can propagate to deletion of multiple records. All right. So These were the write operations. Now on each write operations, we have something called the write concern. Okay. In the older API, this is how we used to run it. But now I think it is there in db.x.insert insert and dot help. Okay. So we can say, I'm sorry. So you can see all of these documents right here. So with respect to when you insert an object, this is the syntax and these are the other methods. So I think in the newer API, the insert itself has the right preferences. MongoDB insert. Okay, just give me a minute. Right. So in the insert itself, as you can see in the latest API, okay, this is changed in version number 2.6. You can define your whole documents, okay, and basically, and then you can have the array or a document on an array of the document here, and then you can define your write concern, okay, whatever it was there earlier. So and you can think of this way. You can say that x.insert insert, and then you have this, or you can say users here, and that's it. Okay, and you have a square bracket here. Okay, so this is how it looks like. It looks like in terms of insert. Okay, so db dot your collection name and then insert, and then uh, uh, curly brackets. Under this, you can either specify the first argument as the document if it is starting with the curly brackets, or you can specify it as an array of the documents which you want to insert in a single insert, and you can say ordered equals false, which means there will not be MongoDB will not be following any order per se. And you can specify things like this: write concern, where my write concern is majority and write timeout is something. Okay, so this is my write concern. In your preferences of the insertion, these are the preferences. First one is whether ordered or not, meaning I start inserting the second one only after the first one is successful. And there are something called write concern. Write concern has two parts called this write real concern and write timeout. Okay, and basically the default write concern is, I mean, write concern as in what kind of, how much concerned are you for writing anything into this collection, whether you want it immediate feedback or you are ready to wait till the response comes in, whether you want to ensure that the whatever you are trying to write to the database gets written and replicated to all the machines, or you are okay with I mean, you want to quickly get a response that database will write it in future. Okay, that's all. Okay, so based on your requirement of how much hurry in how much hurry are you, whether you want to quickly write and move on, or you want to make sure that it has written properly and only then you want to move on. So based on your preference or based on your concern, you can define the various criterias. Okay, here, So first one is unacknowledged. Okay. And the default one is acknowledged. Okay. We'll come back to that. First one is unacknowledged. This is the fastest way of writing, but there is no guarantee. Write concern is nothing but a sort of a guarantee provided by MongoDB based on how much concerned are you. Okay. If you say unacknowledged, then there is no guarantee provided by MongoDB to you. Okay. And guarantee in terms of uh, mm, in terms of whether it will be written, and if it is not written, then will you be informed or not. Okay. So if you say unacknowledged, that means the MongoDB will quickly take the document from you, and you will carry on quickly. You don't have to wait for the operation, any operation to happen. Okay. So W equals 0 is the one which is called unacknowledged. Okay. Or you can specify like a string also. No issues. It accepts in both the formats. Okay. So when you are saying insert, let's see if this guy does not provide you. Okay. And I say here, I say ordered equals false, and I'll have to put one more curly bracket here. Is my screen visible to you guys clearly? And my right concern is okay. Okay, I'll give a real life example. I'll give a very real life example. You will be able to majority, okay, and you say right timeout is okay. So where did I miss? So this is the inner one. This is right, right? Maybe the API is old or something. Okay, this is correct actually. This is correct. So this should be it. What is this? This is right. This is correct. I think that there's some API gotcha. No worries, I'll just check that out later. Okay, so let me answer to Anu's question. Anuj is saying that any real life example of real life example. Just let me increase the volume if I can do that. Okay. Hmm. It should be loud enough now. Okay. So let me take a real life example of the use of the right concerns. Right. Now, in case of, say, you are building a website like uh, uh, like, say, for example, Amazon, right? In case of Amazon like website, all the data which is being written as your say as part of say metrics, when you are when the website is being displayed, there are a lot of metrics is being logged by the system into a database. Okay. Now every time a matrix is being logged, if it waits, if it waits for metrics to be logged, then your user is getting impacted, right? Your overall time goes really, really bad. In those circumstances, you want unacknowledged kind of right concerns. Okay. Because your first preference is your website should be fast, and second is that its time should be noted. Okay. Because your users come before your an- any of the infrastructure. Okay. So therefore, you do not want your customer to wait because you are noting down all the metrics here and there. All right. So in such circumstances, you always prefer unacknowledged kind of kind of concern level. You're not so concerned about right. Okay. When I say not concerned, there could be a chance of failure, meaning a disk failure failed or something happened. In those cases, your right might not be persisted and you may not be informed. Okay. And but okay. So that is what it is. And there could be multiple cases. It will be completely your call while deciding on what kind of, basically, it will be completely your call which right concern label are you going to use. Okay, so the ideal way is you always keep the customers in place, in front, I mean, the users who are going to access your website or who is going to use your service, and then you walk backwards and figure out at what levels, at what points do you want right concern label. Say, if they are doing a transaction, you want the transaction details to be logged with without any failure possibility. Okay, that should not, basically they paid and it did not happen, should not be the scenario at all. Okay, so this will be more of your calls. Okay, your decisions, and that is why MongoDB gives you a way to do this. Okay. Now the second one is the acknowledged one. Okay. So MongoDB will confirm that the write has been received, okay, from you, and then it will be written. Okay. So MongoDB takes from the whatever insert document you have given, it takes it and tells you that it has been received. Okay. And if there is an error while writing to the disk or while accepting, it lets the client know that there is an error. Or say there is a duplicate key over there. In those cases, it will let the user know. In unacknowledgement, those kind of errors are also not detected, also not informed. All right. So those are the kind of scenarios. I mean, In case of acknowledgement, if there is a duplicate ID or some other network traffic error, those will be communicated back to you immediately. If if the if there is a fail, I mean, while actually persisting, if there is some other kind of error, those may not be communicated to you immediately because the write has not happened yet. It has written down in the ledger book. Okay, and those kind of things. An unacknowledged one is that even if there is a duplicate documents already and there is a duplicate key, it doesn't give you an error. Okay, it will drop the write, but it will not give you the error. Third one is that journaled. Journal is a concept which comes from accounting, where all your transactions are noted down in a rough book. Okay, all the transactions in a single notebook from top to bottom. A person keeps on noting down, and at a later point of time, every day, it formalizes them into double accounting kind of procedure. Okay, so that is what we call it. Okay, now let me go back. So W equals 0 is unacknowledged. W equals 1 is acknowledged. So of course, W equals 1 is slower than W equals 0. Okay. Because that is the sole objective of having these. Because this is going to do further more checks as compared to unacknowledged, which is W equals 0. And W equals 1 is acknowledged. So this and this one is going to take a little more time. So W equals 1, and this is how you say, okay, journal equal to true and W equals 1. Okay, basically it is a similar label as acknowledged, just that it is going to get written into something called a journal into the disk. The only difference between acknowledged and journaled is, in case there is a power failure, immediately your writes will not be lost. Okay, because this has written it to the disk. Okay, and also you can think of journal as basically a file kind of a circular buffer, I mean file kind of a buffer, where which keeps on writing to the disk as you are writing to it. Okay, it keeps on writing to the disk as you write to it. So that's the kind of thing. So first, Mongo, in case of write concern equals 1, which is journaled, as well as journal equals to true, then MongoDB will first apply that change, put it in journal, and start writing. I mean, journal is anyway being written. So your information is going to be written to the disk very, very quickly, and then you get a response. And later point of time, that whole journal is transferred to the individual table. Yeah, this buffer is decided by the Mongo itself. Journal size you can specify, journal location into the disk where it is going to write the journal, you can control that, because in case your database and journal are on the same disk, that means you do not get any added advantage of having a journal. Okay, because the main problem with the disk is that when you try to write to it, it consumes, it can only write one thing at a time. Okay, so if you are writing to the journal, it is going to impact your normal table writing. Therefore, journal is very well controlled by you. Okay. But I'm not very sure if it also gives you a granularity on journal size. Okay. Because journal, yeah, I think journal size is expandable. I think journal size is expandable. Right. Because in the circumstances where you have fast writes, as in you are updating a table very frequently, continuously, in those cases the actual space is smaller, while your journal has to be big to handle those kind of scenarios. So you can fine tune your journal. how long the data remains in journal. It all depends on your journal size and number of records. Number of basically the difference between a journal is basically, how should I describe this? So it all depends on how big the journal is keeping a buffer. Okay, it has some predefined numbers, and based on that it will have those. And the second parameter which matters in this case is what is the writing speed of your hard drive, whether you are using solid state or hard drive or some other mechanisms. It will depend on that one. Okay, now the second one is, which is called W2. I mean, it's called basically its fourth one is W equals true, and basically it means the replica acknowledged. It means that MongoDB will take the write operation. As we all know that write operation is accepted by primary. Primary takes that operation, and at least one of the secondary servers tell acknowledged as in this acknowledged. Okay, so one of the secondary ones, once they tell that, oh, I am acknowledging it, immediately the customer will get a response that your data has been written with the right concern as replica acknowledged, meaning one of the replica, at least one of the replica has got the data, meaning you have got minimum of two copies of your data, one at the primary and other is at the replica. Okay, so that is called replica acknowledged. All right, which is W equals to true. So we talked about, first we talked about unacknowledged, acknowledged, then journaled, and then we talked about replica acknowledged. All right, here, and I think there is one more missing over here. There is one more missing, I think. Okay, there is something called majority also. Majority means if there are one primary, two secondary, or say one primary and four secondaries, or say three secondaries. So total number of replica members in the replica set is 3 plus 1, 4 members. So until it finishes writing to 3 members, it will not give the response to the user in case of majority. Alright, so that is called majority. So meaning in a replica set, the data has been written to majority of the machines. Only then you will get a response. Now, as I was telling you earlier also, the write operation performance is a function of multiple things. Okay, first is indexes, because every time as we were talking that whenever you insert a record, it has to find a position first where to insert this in the index. Okay, so every time you add a record or add a document in the collection or add a record in a table, indexes are updated. And if you have got 5 indexes, it is equivalent to 5 searches onto the index plus the time taken to write to the indexes. Okay, so actual value writing, because you might have to move, rebalance, and all those things you might have to do in the tree. So basically index updates take the time, not as much as the search might take. I mean, it won't take too much of time, but it does take. And the more the index is, the slower it gets, right? So to optimize your write operation, you might have to drop maximum number of irrelevant, basically irrelevant indexes which are no longer required, Second parameter for the write operation is the document growth. Okay, meaning if the record size crosses, the document need to be moved. Okay, in the cases where you are you know using a very fixed document size. Okay, in case of as we explained that you can have two strategy for writing a document. One is a fixed one and other is power of two. Okay, so the moment document size increases or document increases, it has to relocate from the from the one location to another, because there is no more space left for its expansion, and hence write operations are heavily impacted by that behavior. Okay, so the other part we mentioned is that the hardware. If you have SSD, solid state hard drive, which are pretty fast. Okay, okay, so I have got some question, I'm sorry. Where are the indexes stored in MongoDB? Same space as collection. Right. They're stored as separate documents. You're right. So similarly, when you are journaling, meaning you are maintaining a journal, also you are enabling a journal on a database or in a MongoDB, it might affect the performance really bad if both journal as well as the actual document both stored on the same disk. If they stored on the different disk, then also it is going to do write operations twice, and hence the performance might actually slow down, but there is a guarantee that your write operations are safe. Okay, in case of MongoDB you have bulk inserts also, but there is no guarantee that all of these documents will either committed or not committed. Okay, but there is a guarantee that each document will not be partially added into the database. Okay, out of the list, some might get added, some might not get added, but out but it won't happen that out of a single document half of the document got written and half of the key value pairs are missing. That will not happen. Okay, which means that each document insertion is atomic, meaning that in case of a single document, either the whole document is added or nothing gets added. But in case of there are multiple document bulk edit operations, if there is no guarantee that either or all kind of guarantee is not there. It might happen that 50% of the document are added, 50% are not. Okay, and this definitely improve bulk inserts, definitely improve performance, because it doesn't have to do a lot of operations in a single shot. I mean, it basically optimizes a lot of operations like logging, like um, I mean, yeah, I mean, finding a location where to add a document. So if you are adding multiple documents, it is actually easy for MongoDB to, you know, I mean, finding the location where to insert the document on the disk and then adding the next document next to it is fairly fast. And hence, bulk inserts improve the performance in case you are adding a lot of documents into MongoDB. Okay. Right, it is exactly like insert into the table and select star from the table. So, okay, okay. And there are other than bulk insert. When I say bulk insert, I say db.mycollection.insert and then I pass an array of the documents. Okay, so that is bulk insert. There are two more ways to do a bulk insert. One is Mongo import, which basically imports the JSON collections from a file. Mongo restore is, it basically takes the BSON format data. Sorry, Mongo import takes various kind of formats. It can be CSV, it can be something else. It does the import. That is equivalent of having a ETL tool. A Mongo restore is the one which basically takes the previous backup of the database and restore it to the database. Okay, so those two tools help you from in bulk inserts other than your db.inserts. Okay, now here, now we are starting with a concept called data modeling. Okay, so do you have any questions till here right now? We talked about inserts, we talked about write operation, we talked about write concerns. Okay, and write concern labels, yeah. So basically, till now, we had been only talking about CRUD operations. Okay, the CRUD operations, basically the way the query happen, how does the index work, how does the distribution of the query might work, and how do the read preferences impact your data, queries, how does the write concern impact your insert and updates. So that's what we had been talking till now. Okay, now there is a concept called data modeling. Okay, it's not a new concept or new thing. It's a basically you, how do you explain? So basically, a data modeling is a best practices kind of thing. Okay, so Kamlesh is saying declare ID equals 0, select star from table where ID equals 0 or ID equals 0. Okay, select star. What is the role of this ID? Basically, what you're saying is you defined a variable. I'll show you this. Okay. So basically, db.x.find. Okay. It doesn't have anything. Let's just add something. Okay. Let's just add something called ID equals 1. All right. ID equals ID is just another field right now. It's not a primary key here. Okay. So db.x.find, what is not this? We are going to insert, not find. Okay. So I'm answering to Kamlesh's question. He has asked, how do you do this kind of thing? So now we have got this table. It has got a field called ID equals 0. And let's also add something called name equals me and ID equals 1. All right. Okay. Now, if you can see that you have got two rows, right? And when you say declare, you say ID equals, let's call it ID, say, I'm just defining another variable, or you can just say ID equals 0, okay, right? And then you say db.x.find, okay, my ID is ID, this will find work. Okay, so you got the first one. All right, and similarly, if you can do this, you'll get the second one. All right, was I able to describe you? You could put or here. Okay, you could put or here, and then you could do array here. Okay, like this. So you say or, and then you say this, not this, not this, not this. I'll show you. Let me just see. He wants to say how this query will work. So I gave you an example, right? So this way you can query your data. Fine. Wait, 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 wait. How this query will work in MongoDB? This is answered. He wants to say if input to query is 0, then return all records, else return specific records which matches input. Okay, okay. No, in these cases, when you talk to MongoDB, right, you can form all of this based on, I mean, you can form or kind of operators as we talked earlier in easily. Okay, okay. It's just that right now. So here we have, okay. Now what do you want to say is either this, okay, okay. Oh, okay. Now I got your question. Basically, what Pramod wants to is saying is right. So basically, in those circumstances, you put a if clause in the JavaScript itself. You say like something like this. You say uh, if, or you can say ID equals 0, and then question mark, and then say db.x.find, okay, or db.x.find, and then you say id colon id, and then that's it. Okay, now if you say id equals 0, now the same statement will return you both the rows, right? This is what you wanted to say, Kamlesh? Is this what you were expecting, Kamlesh? So if id is 0 here, id is 1, okay, in those cases only one record is being returned. In case id is 0, then in those cases you are getting both the records. Alright? Great question, by the way. Hope everybody else also got what I'm trying to say. Similar to your C language and other programming languages, you have these operators in JavaScript as well, where you can put a conditional ternary, tertiary or ternary operator, we call them, id equals 0, while in this find clause the first one is column name and second one is the variable name. That should be noted, okay, because the first field, the key, cannot be a variable. That's why it always assumes that to be a string, okay, and that's what it is. So who all got this query, what I have just written in terms of MongoDB, or who did not get? Okay, great, 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 great. Okay. Okay. I'll have to mute somebody. Okay. So good to move on with data modeling. Okay. So there is a deviation from what RDBMS provides. In case of RDBMS, we have a certain other methodology for modeling your data. Those who have been from RDBMS background, they very well understand what is normalization, how do you store, how do you convert any object into various tables, right? But here there is a little bit of difference. So what exactly is the objective of data modeling? Data modeling determines what will be the structure of the data, okay, in terms of the facilities provided by a database. How do you query it? How do you save it? Okay. This also is also referred as data structure interchangeably. And when we are talking, we will also talk in terms of we will talk interchangeably in these two lingos. Okay, data structure and data modeling. And it represents the nature of the data. Okay, it represents the nature of the data. What kind of data are we dealing with? Okay, whether it's a business and what are the kind of constraints we have on the format of the data. Okay, these are the sort of, there might be a business rules which are governing the data and how it will be organized in the database. Okay, so this is what is generally our data modeling's objective is. So you are given a problem, how are you going to structure your data such that it solves the problem and also is efficient. Okay, why do you need data modeling is quite obvious, because it needs to it this basically data modeling is something like catering to the objective catering to the objective while keeping in mind the performance characteristic of the database. Okay, so like as we talked about that inserts take so much time, there is a basically if you keep on changing and increasing an object, then it is going to move from one place to another and going to relocate, and there is a upper cap on each document size. Okay, so therefore you need to balance between what you need from the user, from your basically what do you need to provide to the developer or to the user, and what does the database provides. That is the fine balance that data modeling need to achieve. Okay, so in case of MongoDB, a document is basically a merger of all the documents, all the information in one place. Okay, just like this. Okay, it has got everything. Had it been had it been uh, so it it is basically this object is representing myself, my education, what kind of music I like, what kind of skills I do possess, and and the other criterias. Okay, it is always, in case of MongoDB, it is in the form of a document. The schema is flexible. Okay, meaning you are not having the constraints of the same number of columns. You can have multiple different fields and still have index on those fields and look up pretty fast. Okay, even though there is no schema, indexes are very well supported, and hence looking up for information and retrieval is very well supported and pretty fast. Okay, so each document writing, update or deletion always happen in the either completely happens or nothing happens. There is no mid state. Okay, so hence there is a atomic rights, and that is the reason to achieve the atomic rights. That's the reason we have a single server called primary, which takes care of responsibility of writing to a collection. Okay. Now, same document, what we have seen here, a document representing a person, how does it look in case of relational database? This is how it looks in case of a relational. So we have a table called person. This one has got a person ID and person name. Then there is another table called music likes, what kind of music this person likes. It has got an ID and music, and so on. Then there is a third table called sports likes. It has got a column called ID and a music, not music, sports. Okay. Now there is education, there is another table. So this is called a normalized form of data in relational model. Okay. We created every subdocument is some, basically every field has to go separately here. Every subdocument is broken down into various documents, and they are all related by ID in these fields. So when you want the whole object, you will have to join how many tables? 1, 2, 3, 4, 5 tables. Okay. And when you put where condition, 5 different tables are going to be queried. Okay. So hence, when you have an object, something like a Facebook profile, you might end up having hundreds of tables, okay, for just representing one person. And these tables will keep on adding day by day. You modified just one field to something else, you will have to upgrade all of the data. And also you might end up creating more tables, and hence your joins will get impacted. So sometimes, although this model is mathematically perfect, okay, relational model is mathematically perfect, but it becomes inefficient when you have lot of queries happening on person table. So so if there are a lot of query happening on person table, or a lot of time, every time user is logging in every millisecond, you'll have to form this object. So you end up, as soon as the load grows up, you end up removing these tables, creating a something called object cache, in which you'll just keep the person over there instead of these tables. And when an ID for a request comes in, you just serve from there. So slowly, if you are using a relational data model, slowly you will start moving to cache. Cache is not really great with respect to storing object. It will, again, you will need something like a MongoDB in the end, who has the ability to keep an object immediately for serving, right? So, and that is exactly the reason why MongoDB came into place. Because this mode of working, relational way of working, was not efficient. It might have been mathematically perfect, but it was not efficient. It did not work out when we had so much of load. Okay, that is why people ended up having MongoDB as the main source of data. Okay, or MongoDB or document object, basically document databases. Therefore, so these are the two different databases, two different formats. First one is where each of the information is part of the single object. Here, information is sliced out so that the information of the exact same type is stored together. Okay. And whenever you need to form the complete object, you need to join these things together. Okay. And so on. So whenever you are going to answer in terms of, now here, this portion is called embedded. Okay. Right. So say tomorrow you have more likes. Okay. Say more and more, how should I describe? 23 and 24 slides. Okay, 23 and 24 slides are basically telling why do you need data modeling and what is data modeling. Basically, a data modeling is converting the need of the user or need of the application in terms of what kind of collections you will need, what kind of whether you will add all the data into a single collection or in different collection. That is that is the that is what we discussed in data modeling. Okay, basically why do we need it, what kind of data modeling is, and basically the whole idea and the whole trade-off you will have to make is whether should I create an array of documents or should I create a separate collection. Okay, so so if you have education like this, okay, like in this format, can you see what I'm editing right now? So if you have education in this format, and we have say post graduation, okay, or I'll take a better example, post graduation, okay, and I have something here, and that means what will happen at the end of day is if I'm so should I create another table called person underscore education and put all of these sub documents as independent documents? Okay, or should I leave it as is the way it is right now? Okay, so those are the kind of trade-off you will have to think about before when doing the data modeling. So first trade-off is whether to go with embed or reference. So if you are embedding something here like this is embedding a document inside another one. If you said education equals and here you say education and then you say put some id number 123 which is the id in another table, then it is called a reference. Okay, so the first call you will have to take is whether to refer to a document, meaning move a sub documents to an external document with its own identity, or keep it embedded inside a document. That will be the first call you will have to take, exactly like foreign keys, right? And and then whether to create a capped collection or not. In case your update are all you are doing is inserting and there are no updates, and inserting is fairly, you know that the size of the data is fixed. In those cases you might end up using capped collection or you might having a normal collection. Okay, third call you will have to take is because creating indexes is a fine line. Okay, so whether to create indexes or not. So as a rule of thumb, any field on which you query, you should be creating the indexes on that particular field. Now fourth is what kind of padding strategies you will be settling for, fixed or power of 2. Again, in case your document keeps on changing all the time, there is no such thing. In case your document is fixed size, then you will go for a fixed one. In case your document varies, there are updates from time to time, then you might go for power of 2, or completely move that sub document to elsewhere into separate collection if that change is really heavy. I mean, if there are changes really fast. Okay, and and there is something called TTL indexes. We will talk about TTL indexes. TTL indexes are also a kind of indexes which which basically trigger which basically trigger a time-based deletion. Okay, they are called indexes because it's the same mechanism to ensure indexes. Basically, anything which lies in the TTL index gets deleted automatically. So what kind of TTL indexes you will need? Based on your data requirement, if your data has to vanish after some time, you will use TTL. Okay. So what kind of TTL? These are the calls you will have to make. These are the decisions you will have to take. Similarly, and now let me talk about one by one. Okay. So first one was embed or reference. This is what is meant by embed or reference. Okay. So you have a user document and you have a contact document and you have a access document. Okay. Meaning there is a particular person. Do you store his information at two separate documents, or you store his information in a single document like this? So there are two different models, like this or like this. How do you, which one do you choose and why? Okay. So first solution to this is, first is that you, or if your contact details are being added very frequently, as well as access document is also being added frequently but in a separate at a separate pace, then you will have this kind of mechanism. If these contact documents and access documents are not being appended or being changed frequently, then you will have this kind of format. So this is the call you will have to take all the time, because inserting a document is easier. As we talked about, padding and all, inserting a fresh document is easier than updating an older one. Okay. Although these things are not very vivid or very apparent when we talk about hundreds of documents, but these things become very lagging. They become the bottleneck when you have millions of documents being added or updated. Okay. So your velocity of the data will decide which architecture do you choose. Okay. So you use references when contact documents are being updated very frequently. We frequently need context document info only. The access pattern and the write patterns vary at a different paces. Okay. They have a different velocity altogether. Now second is this one. We use embedding when we need atomicity. Remember, atomicity. Here, when we are updating the user document as well as inserting into access document, there may not be a transaction. Meaning, we cannot guarantee that both the things happen together or don't happen at all. Or both the things happen or don't happen at all. That kind of guarantee is not there. But when you are adding documents into values into a document, then there is a guarantee that it gets added together. Okay. While the transaction, there is a possibility of creating a transaction, but there is no guarantee at all. Okay. But that is too hacky. Wouldn't contact always be at the user label, as contact always be unique? Access can be embedded. Yes. So if your access document is not changing very frequently, then that model would be better. Okay. So Rizwan was asking something. Is reference easy to manage? Mm, it all depends on your access pattern, Rizwan. Okay. It all depends on your access and writing pattern. Okay. Completely. Unlike, because it is from the management perspective, it is same. The only problem with reference is that there is no guarantee of the transaction, and that might become a problem. Okay. So based on your requirement, if you need to frequently keep on adding access documents all the time, while your contact document and user document is not changing at all, in those cases you merge user document and contact document together while keeping access document as a separate collection. Okay. So basically this becomes a collection, these two becomes a single collection, go into the single collection, and so on. Okay. So based on your pattern, keeping these two three things in mind. First is atomicity of the whole document is there, but and and the second thing you have to keep in mind is that when you have document in multiple places, there is a effort required to merge these information. Okay, there are no joins straight away. Okay, there are no joins supported by MongoDB so far. Okay, there are discussions, but they're saying no to the joins yet. Okay, if you have to join it, it will be basically taking up a document, picking up the references, and then looking back in the MongoDB for the document which is being referenced. All right. Now, similarly here again another example I've taken. So, say you have got orders. Okay, here. So since orders keep on coming from the user very frequently and customer information, name, ID and other information doesn't change, it makes a logical sense to take out orders and keep it in a separate collection. Okay, because the pattern of the modification pattern of orders is different from customers. Okay, similarly you have something, I mean, here it might look that both the documents belong together. One is dev, other is debug. But the rate of generation of logs, okay, these say, imagine that you are taking logging the documents, logging into MongoDB. Whatever is happening on your website, the logs you are pushing into MongoDB. Now, there are two kinds of logs. One is developer level logs, other is debug level logs. Okay, development level or say deployment level. Let's assume for time being. Now, both these logs has different behavior altogether. Debug logs are extremely high, while development logs may be lesser. And there are different set of users who need these information. Okay, while debug logs can be discarded, dev logs cannot be discarded. Okay, and and therefore in these circumstances, if the patterns are completely different, even though the data is similar, you might have to split them into two different collections. Okay, so these all approaches are mostly performance governed. Okay, basically performance is the first criteria, convenience is a little secondary criteria. Okay, because you might have to keep these data together in different databases, different collections, and hence you every time you access this, you will have to access twice because they are existing in the two. So convenience is being impacted a bit, but in favor of performance, we are splitting these two. Okay, and the other reason of doing this is, I mean, why the performance might get impacted, because if the first one might increase pretty fast, while debug logs may not increase that fast, and hence both might have a different kind of replication or sharding policies. Replication policies, as in, to how many machine do we want to replicate it? Okay, what kind of guarantee we are needing? What kind of right concerns we want? So based on those kind of all the information, you decide upon whether to embed or reference. Okay, right? So this is what we discussed. And also, and the last one we will discuss again when we go detailed into indexes. Okay, go and do the detailing of the indexes. Okay, the TTL meaning the document gets deleted. Okay, after some time. Okay, now, right. Okay. One more thing, like some of us have just taken the search the internet for the question, and whatever you have got, you have just pasted those ones, those answers. So I would expect that you basically go through searching is fine, looking for the data online is fine, but you should be writing your answers in your own fashion instead of simply copy pasting. Okay. I went through your answers very quickly. Some of us has done that. Okay. So this is pretty much for today. So do you have any questions for me now? Feel free to ask. Anyone? Either I did not explain properly or I explained really, really well. Those are the only two reasons why no questions are there. Or you have to rush somewhere. Okay. Suppose I have index on name in a document, okay, but I don't have name in other document in that collection. Then indexing won't be helpful. No, indexing will be helpful, right? Or is there any way Mongo does it in this scenario? Very good question, Rizwan, again. So I would say that basically, let me give you an example. Okay, let's just imagine that first document is having name, okay, and second document does not have name. Let's call first name. Okay. And third document is there which has got names. Okay. So when indexing happens, right? Indexing will basically completely ignore the second document while take care of the first one and second one. And when you are looking for, say, let's call it this one and some last name. Okay. So when you are looking for something like this, okay, name equals sen, then this index will quickly look into find these two documents and give it to you. Okay. And in case you also mention kind of putting or somewhere. Okay. I'm just putting or here. Okay. Like this. Okay. So in case you put or here, then what you do is you can have f name equals. Okay. So you can have indexes on both f name and name. Okay. Because in case you are putting a query like this, both the indexes will be used and exploited, and the answer will be given to you. Okay. So index it doesn't mean if some of the documents are not having that particular field, it still makes sense to index those documents. Okay. Any other question you have? Sanjeev? Sanjeev Mohan? Okay. Okay. Yes, we can have nested index. Yes. I will give you those demonstrations maybe a little after a little while. Basically, if you have something like, let me just show you this. Okay. Uh, so let's say you have got place. Okay. Place has got another document. Okay, like this. Okay. Place has got city, and city is Mumbai. All right. And in those cases, it is quite possible to have a document like this. Okay, I'll show you this. So db.x.insert, okay, and I'm adding this. Oh, what did I do wrong? So we have got place. Okay, here I need to put a comma. Okay, so I say db.x.insert and then like this. Okay, and we say db.x.find, and this is what we get. Okay, now we can say ensure index on place dot city, and we can say that. Okay, okay, all right. So it is created, the index is created, and when you say find, all right, when you say something like this, find, and when you mention Mumbai, okay, you get the city. Okay, and you can say explain, right, and it will show you there is a B cursor on place dot city underscore one. Okay, was I able to answer your question? Great, great, great. All right. So basically, this is how you create indexes. We will dive deeper into querying and various kinds of indexes and how to create this, how to create that, and those details we'll get into. Okay. Or have we gotten into those details yet? The various kinds of indexes? Okay. Not yet. Okay. Yeah, we'll get into those details. Okay then. Yeah. Okay. Okay. Any other sorting method can be used in Mongo, or it can be done. So Rajita, binary search I had taken only only for the explanation's sake. Okay, binary search was just for converting the whole searching technique into explanation way for the purpose of simplicity. Under the hood there is a construct called B tree. Okay, B tree, if you are technically inclined, you should look at B tree because that is the standard way MySQL, MS SQL, or Oracle, all of they use B trees to have the indexes. Okay, B trees are sort of binary trees, but the below or lower nodes are into the hard disk and the upper nodes are into the RAM, making it possible mm, so that there are less lookups to the disk, and we can we can index really huge data. If it is completely in the RAM, then the speed is fast, but RAM is generally smaller, so you cannot keep everything in RAM. And if you keep everything into the disk, then lookup is extremely slow and it is almost impossible to do a binary search in the disk. That is why there is a midway called B tree in which half of the top nodes are into the memory while lower nodes where the lower nodes are into the disk, which means there are only one or two lookups onto the disk whenever you search in the indexes. Okay. Okay, but if you are inclined, you should actually understand how does B-tree data structure works. Okay, and this is the most simple explanation I could come up with. Okay, But you should look at the B tree kind of a tree in the Wikipedia. All right. Great, great. So that is why these B tree kind of data structure, these are industry standard, and there is no point in switching to any other data structure. Okay. All right. Thank you, everyone. It was a wonderful class. It was a wonderful class, and I got absolutely great questions from people. Feel free to drop me an email. I'll reply to you. I'll reply to your assignments on Monday. Okay, or maybe Tuesday. That's all. Okay. Thank you. See you tomorrow, Umang. See you guys tomorrow. Bye bye. Thank you, Sanjeev. And drop me an email in case you have any doubt or any problem, or give me a call in case of any problems. Thank you. Thank you, Sanjeev. Great. Bye bye. Bye bye. Bye, guys. I'm hanging up now. Thank you.